So the example we are starting with is 3x squared plus 4y squared equals 16, and 2x squared minus 3y squared equals 5.
I hate this stupid desk.
You can move to a different desk, honey. Or you can just switch it out with another one. That's okay too. Remember, when we're doing elimination, my goal is to cancel out one of my variables by multiplying one or both equations by some number to force them to cancel out. So the first thing I need to do is I need to identify which variable I'm hoping to cancel. So we can either cancel the x or we can cancel the y. What do you guys vote for? Okay, show of hands. Who thinks x? Who thinks y? I'm going to go with y. Can you guess the reason?
There's already a negative and a positive number.
One of them is positive and one of them is negative. So my signs are already different, which means now I just need the numbers to be the same. So what do 4 and 3 both go into? 12. So I'm going to multiply each of these equations until that y variable is a 12. So what do you think I'm going to multiply the top equation by? 3, because 4 times 3 is 12. What am I going to multiply the bottom equation by? 4, because 4 times 3 is 12. So I'm going to go ahead and do that and rewrite the new equations off to the right-hand side. So when I multiply the top one by 3, I get 9x squared plus 12y squared equals 48. When I multiply the bottom equation, I get 8x squared minus 12y squared equals 20. And then I always add straight down. When I add straight down, 9 plus 8 gives me a 17x squared. 12 and negative 12 zero out, which is what I wanted to happen. And then 48 plus 20 gives me 68. So now I have 17x squared equals 68. My goal here is now to solve for x. So what am I going to do first to get x by itself? Divide each side by 17. So when I do, I get that x squared is equal to what? 4. And then I do what? Square root it, and I get x is equal to what? And, okay, so we have to remember that when I take the square root of a number, I get 2 answers, because I get a positive answer and I get a negative answer. So this gave me 2 x values here. Everyone okay with that? Is anybody confused about how I got the 2 x values? Yes. Okay. So I worked through it. Are you okay with how we got to like here? So then I divided each side by 17. I got x squared equals 4. Then what's the square root of 4, Brandon? And negative 2, because 2 times 2 equals 4, but so does negative 2 times negative 2. So we have to remember that the negative is also a square root. What am I going to do now?
Plug in x to x squared.
Plug in x to the x squares in one of these two equations, and I'm going to solve. Does it matter which equation I choose? No, it does not. I'm going to go ahead and go with the top one, just because, I don't know, it seems like the easier one. So I'm going to plug in 2, and then I'm going to plug in negative 2. We're going to start with 2. When I plug it in, I get 3 times 2 squared plus 4y squared equals 16. 2 squared is 4 times 3 is 12 plus 4y squared equals 16. Subtract the 12 over, I get 4y squared equals 4, which tells me that y squared equals 1. Then I need to square root both sides. And what is the square root of 1? And, okay, so I got y equals 1 and y equals negative 1, which means one x value gave me 2 y values. So this is going to give me 2 solution points, 2, 1, and 2, negative 1. And then I'm going to repeat the process with x equals -2. So I plug it in, I get 3 times -2 squared plus 4y squared equals 16. I simplify it out. -2 squared is 4 times 3 is 12 plus 4y squared equals 16. Subtract the 12, I get 4y squared equals 4. Divide by 4, I get y squared equals 1. I square root both sides, and I get y equals what? Positive and -1 again, which means this gives me 2 more solution points. -2, 1, and -2, -1. So in total, I had 4 solutions to this system. Questions, concerns, or issues? Does that process make sense to all of you? Anybody confused by any portion of that or how I got any portion of that? We're all good? Okay, let's go ahead and move on to the next example. We only have about 3 examples left, so that's awesome. So the next example, again, has 2 equations. I have 3x squared minus 2y squared equals -5. And then I have 2x squared minus y squared equals -2. What's going to be my first step here, Madison? Okay, so to pick a variable that I want to cancel, what do you want to cancel here? The y, okay. Why did you pick the y? Just out of curiosity. Because you would only have to do the bottom one. Okay, so she chose that we're going to cancel the y's because it involves only multiplying one of the equations by something to get it to cancel out. If I wanted to do the x's, I would have to multiply both equations. Either one of those would have been okay. It doesn't matter where you choose to start. I, like Madison, choose to go for the one that involves the least amount of work. So if I am multiplying this bottom equation in order to cancel the y's, what am I going to multiply it by? -2, because I need that to become a positive 2y squared. So it cancels with the -2y squared in the equation above it. So we're going to multiply by -2. When I do, my first equation stays the same. And my bottom equation becomes -4x squared plus 2y squared equals +4. From here, I add straight down. 3 minus 4 is a -1x squared. -2 and a +2 cancels out. And then -5 plus 4 is a -1. So I have -x squared equals -1. Brandon Bailey, what am I going to do next?
Square root.
Nope, can't square root it because I have a negative in front of my x squared right now. So multiply everything by -1 or divide by -1, it doesn't matter. I'm going to divide a -1 out. And when I do, I'm left with x squared equals +1. And now I can square root both sides. And when I do, I get x is equal to what? Positive and -1. Which means I'm going to have 2 x values that I now have to test. Does it matter which of the original equations I choose to plug it back into? No. So I'm just going to pick one. I'm going to go with the bottom one, just for fun. So I'm gonna plug them back in here. I'm gonna start with x equals 1. When I do, I get 2 times 1 squared minus y squared equals negative 2. 1 squared is 1 times 2 is 2. And then minus y squared equals negative 2. I'm going to subtract 2 across, and I get negative y squared equals negative 4. Divide everything by negative 1, and I get y squared equals positive 4. I'm going to go ahead and square root it, and I get y is equal to what? Positive and negative 2. So plugging in a positive 1 gave me 2 y values, which means I'm going to have 2 points that are solutions that came from x equals 1. Those 2 points are going to be 1 positive 2 and 1 negative 2. And then I get to do this all over again, plugging in negative 1. So when I plug it in, I get 2 times negative 1 squared minus y squared equals negative 2. I'm going to square the negative 1. Negative 1 squared becomes 1 times 2 is 2. I'm going to subtract this 2 across, leaving me with negative y squared equals negative 4. I'm going to divide each side by negative 1, and I get y squared equals 4, which then I can go ahead and square root both sides. And I again get that y is equal to plus and minus 2 because the square root of 4 is positive 2 and negative 2. So when I plugged in negative 1, I got 2 y's, which indicates I have 2 points that have negative 1 as an x value. So I have negative 1, 2, and negative 1, negative 2. And then all 4 of these are my solution. They all have to be there to be counted correct. All 4 of the points. You have to have all the solution points in order for it to be correct. Questions, concerns, or issues with that problem? We're all okay? We have 2 more and then we are finished. I know you're so excited. So this next one is kind of a story problem. I know, you just love it when we add that kind of stuff in here. They're very short story problems, if that helps. So this story problem says to find the length and width of a rectangle whose perimeter is equal to 36 feet and whose area is equal to 77 feet squared. So whenever I'm presented with a problem like this one, what should be the first thing I do?
Write it down.
Draw a picture. Absolutely. What shape is my picture going to be? A rectangle, because it says a rectangle. So it tells me which shape I'm using. So I draw my rectangle. On this rectangle, I have 2 sets of sides. What are those sides called? Length and width. Awesome. I don't know anything about that length and the width, but I do know some stuff about other portions of this rectangle. What's the first piece of information that it gave me about my rectangle?
The perimeter is 36 feet.
Okay, so my perimeter P is equal to 36 feet. And then what else do I know?
And the area is 77 feet squared.
So area is equal then to 77. So I have that my sides are length or width, and I have that my perimeter is equal to 36 and my area is equal to 77. So what I need to do is I need to build that perimeter equation and that area equation for this specific rectangle. So if I'm thinking about perimeter, how do I find the perimeter of a rectangle? All the sides added together. So I could have length plus width equals 36. But that's kind of a lot to write. So I could recognize that I have 2 lengths and I have 2 widths. So this becomes 2L plus 2W equals 36. I can then do the same thing with my area. How do I find the area of a rectangle? Length times width, yes. So I have length times width equals 77 for my area. This is very similar to a substitution problem that we did yesterday. I know it's not elimination because I don't have addition or subtraction in this bottom equation, which means I'm going to be using substitution. So I'm going to have to solve one of these equations for one of my variables. My goal is to avoid having a fraction. So I'm probably going to go with this perimeter equation. And I'm going to pick one of those variables to solve for and then plug it back into the area equation. So what do we want to solve for here, length or width?
Length. Width.
What do we want to solve for? I've heard 2 different answers.
We're indecisive.
Okay, who wants to solve for length? Who wants to solve for width? Hannah was the first one who voted, so I'm going to go with length.
I'm a winner.
So on this equation, we're going to solve for my L. What's the first thing I'm going to do? Grant, what's the first thing I'm going to do to get L by itself?
W across C.
Perfect. So when I move it across, it becomes what?
Negative.
Right. So I have 2L equals, I'm going to say 36 minus 2W. I want L by itself, so what do I do next? Divide everything by 2, and when I do, I get L is equal to 18 minus W. That means I'm going to take this 18 minus W, and I'm going to substitute it into my area equation in place of the L. No, it can't be elimination because I don't have addition or subtraction here. So I could not do that. So when I put it in, I get 18 minus W times W is equal to 77. What am I going to do from here? Distribute the W. So I'm going to multiply it into both of these. When I do, I get negative W squared plus 18W equals 77. So I just reordered them so the W squared was first. And then what do I do next?
Would it be take the 77 and put it into the other side and then
Yes.
use the quadratic equation?
Move the 77 over, and then we're using the quadratic formula. So I get negative W squared plus 18W minus 77 equals 0. I'm going to go ahead and use the quadratic formula here. So my A value is 1, my B value is 18, and my C value is negative 77. Go ahead and plug it into the quadratic formula.
The first one is a negative, but minus 4.
Oh, I did. Thank you.
I was like, okay, so it's gonna come out to negative.
No, you're good. I just wrote that wrong. I know how much you love those. No, that is a negative 1.
Oh no, it is.
I knew it was. There we go.
This is
I knew that was a negative 1. So it's going to come out positive. It'll come out positive.
Negative times negative times
Makes it negative. But if the first number is bigger, it'll still come out positive. Okay, so when we do all of this, we should get negative 18 plus or minus the square root of what? Not the square root of 4. Put in your calculators. What's inside that square root come out to be?
What if I have one?
This is a math classroom, honey. I got 20 calculators over here. Come and get one.
I plugged everything.
Did you plug it all in under the square root though?
Yeah.
That's why.
308. What did I say? 324.
I want just 18 squared minus 4 times negative 1 times negative 77. So we should get a 16 on the square root
Just
over negative 2. Brandon Pfeiffer, what's the square root of 16?
5.
Comes out to be 4. So I'm left with negative 18 plus or minus 4 over negative 2. From here, I go ahead and I split it into 2 problems, 1 addition and 1 subtraction, and I simplify. What do we get when we do this? So negative 18 plus 4 is a negative 14. Over negative 2 is positive 7. Negative 18 minus 4 is a negative 22. Over negative 2 is 11. So we got 7 and we got 11.
7, 11. Interesting. Could we just skip that? That would be area instead of 7, 7, 7.
Also could have been 77 and 1 though. Okay.
My first example, we found 11. It's going to be more.
So what we would do from here is we could take both of those and plug them back in, or we could just recognize that those are my dimensions. I don't actually have to plug them back in because they're just going to give me 7 and 11 as my answers. So the dimensions of my rectangle are 7 and 11. 77 times 1. Well, I'm saying we had other options technically. We had other options technically. The reason that we don't have to plug it back in is because on a rectangle, the length and the width can be flipped. So it really doesn't matter which one we identify as our length and which one we identify as our width, because if we turn the rectangle, it would change. So that's why when we have a rectangle and we get 2 answers, the dimensions are those answers. Okay, as long as neither of them are negative, of course, because we can't have a negative length. Are there any questions on that specific problem? Okay, so we do have one more. And then we are 100% done with this whole lesson. So this next one talks about numbers. Even if you already guessed it, we still have to prove it. Okay. So this problem says that the sum of 2 numbers is 10 and their product is 24. So when I add them together, it equals 10. When I multiply them together, it equals 24. Find the numbers. You probably already guessed what they are, but we're still going to prove it. So I'm still going to need to set up two equations, one for the sum of the numbers and one for the product of the numbers, which means I need to identify variables that represent those numbers. So what would you like to use? A and B. Okay. So A is going to be the first number, and B is going to be the second number. So if I know that the sum of these two numbers is equal to 10, how would I translate that to a numerical equation? A plus B equals 10. Awesome. And then if I know their product is 24 Heath, how would I rewrite that as an equation?
A times B.
So A times B equals 24. Again, I cannot use elimination here because I don't have addition or subtraction happening in that second equation, so it's going to be substitution, which means I need to take that first equation and solve it for one of my variables and then plug it in to that multiplication equation. What variable would you like to solve for in the first equation? A. Okay, that's what I heard. So we're going to go ahead and subtract B to get A by itself. When I do, I get A is equal to 10 minus B. I take that 10 minus B and I'm going to substitute it in for the A in the multiplication equation. So I get 10 minus B times B equals 24. I'm going to distribute the B out. When I do, I get negative B squared plus 10B equals 24. Then what do I do next? Subtract the 24 over. I get negative B squared plus 10B minus 24 equals 0. And now I can go ahead and do the quadratic formula. So everybody do it because we definitely need the practice. My A value is equal to negative 1. My B value is 10. And my C value is negative 24. Everyone do the quadratic formula, please. Beef, you too.
Yeah. Slack.
Brandon, both of you. Madison, did you get a number for under the square root already? What'd you get? No. Make sure we try that one again, okay?
I'm supposed to have an answer.
Emily, what number did you get for under the square root? 4. If you didn't get that, after we finish this problem, of course, go back and rework it, please, because you should be able to plug that into your calculator. So now I have negative 10 plus or minus the square root of 4 all over negative 2. What is the square root of 4? 2. So this becomes negative 10 plus or minus 2 over negative 2. I can then split this into the two problems, one addition, one subtraction. So I have negative 10 plus 2 over negative 2 and negative 10 minus 2 over negative 2. I go ahead and simplify it out. Negative 10 plus 2 is negative 8. Over negative 2 is positive 4. Then I have negative 10 minus 2 is negative 12. Over negative 2 is positive 6. Did that work out for you guys?
Yeah.
Yes, because I got that my two numbers are 4 and 6. Grant.
And what happens if you can prove it just by adding
Nope, I still want it this way.
them?
I still want it this way. So my numbers,
Then you prove it. It's proven if you add them and then multiply
are 4 and 6, which you guys probably already knew. I'm tempted to put eyes on this side so it actually looks like it's staring at us, but I haven't done it yet. Okay, so that was the end of the examples for the nonlinear systems. Your homework is on Canvas and it is due tomorrow, and we will start another lesson then.
So,